Hello, my name is JdeRobot, and in this video I'm going to talk a little about the programming challenge to participate in the Google Summer of Code 2019 under the DGE Robotics organization. In my first post, I talk about the programming challenge. Here, the challenges were divided in three areas. The first one consists in the familiarization with the toolkit. Here you see the compilation log files, some important screenshots about the tool that was run with successful, and also some modules related to the camera. The second challenge talks a little, it's about C++, so this code basically finds the largest pathway inside of a labyrinth. So from a text file, from input, with this pattern, we need to find the largest pathway and replace by those numbers, as you can see here. And here we have several examples. In order to run this code, I have all the instructions down here. So just basically download the code in my GitHub page, go to the C++ challenge and run the command make. And here the last challenge is the Python exercise, which I want to talk a little bit more just to make sure we can run this application in your machine. So the goal of this code is to replicate the game of life. This was a game created in the 70s by John Horton Conway. It basically it's a game that run by itself, so the user just need to choose the initial setup and the code will run by itself, following by its rules. So for example, here we have a really simple configurations, and in the next figure we have a much bigger environment with different patterns. So in order to run that, we need to write a configuration file. Here it's a template how to do that. Basically the configuration file consists in the main that we need to choose the number of lines and columns of the board game, and also the number of steps. Then we have the patterns. So far here we can give a name for the pattern. We can give this write it in a matrix format. We can also say that this pattern should go to a desired position, or the application can choose by itself random. And we choose if we need to add or not this pattern. If it's false, it will not be added in the game. And here's the position. So I'm also providing here several different configurations that you can run. And yeah, that's it. So the first step is to download the tool. We can go to this repository and use the Git commands for that. However, I already have this application here, so let's save some time. So in order to run the Python challenge, we have a folder called Python challenge. So let's access this folder. So here we have all the files necessary to run this application. As I already mentioned, we have configuration files right here, but we also can. I also have a Python application to facilitate to write this JSON format. So, for example, If you want to add a glider, that's the famous pattern from the game. And here we are. So we are going to pick a 10 by 10 board game, run for 40 steps, and this is the configuration. So first let's write the JSON file, and now let's run our application. So here we are. Okay, one more time. So we still have a glider. That pattern is this one. So it's also called a spaceship. So for example, in case we want to add more other patterns, we can copy paste this one, for example. So now I'm going to add 2 spaceships. Just a quickly note, in this file there are several patterns here that I already enter with those. So if you want to use, for example, pentomino, just copy and paste right here and one comment and you'll be fine. But for now, let's run this 2 glider, and we just choose the application. Let's say that this one it's false. So for the first spaceship it will be in the position 0, 0, and for the second one you'll be chosen by the application. So then we need to write the JSON file, the configuration file, and then we need to run the tool. So here we go. So since both spaceships start in different positions, then they get together, so some random configuration can happen. This depends of the initial position. So here we go. Here, just a quick comment, we have a blinker that is never going to die because it's an oscillator. So anyway, there are like several inputs that you can check in my web page. That's it. Thank you. Bye bye.